Hello, future engineers, viewers, subscribers, and students. Here are problems in algebra, and I'm going to present the solutions to these problems. And I hope that you will enjoy watching, learn from the topics in algebra, and hoping further that you can enhance your thinking skills to be better prepared in engineering life. So here is the first problem. A bag contains 5 red balls, 3 blue balls, and 2 green balls. Assume that the 2 balls are drawn simultaneously. Determine the probability that at least one ball is blue. So for the solution, when we say one ball is blue, it means that there is exactly one blue, or there are exactly 2 balls from the drawing of 2 balls from this bag. And for exactly one ball is blue for this situation here, it is either in the first drawing, in the first ball, it is not blue, and in the second ball, it is blue. And for the second case, it is blue in the first drawing, and in the second, it's not. So that's the case for drawing exactly one blue. Then for the 2 balls to be blue, so there's no problem with that, because in the first drawing it should be blue. There are 3 blue balls, and in the second it should be blue again. So therefore, the probability that the 2 balls the probability that at least one ball is drawn blue is equal to the probability that it is exactly one ball plus the probability that the 2 balls are blue balls. For this one ball, exactly one ball, we have probability that it is not blue in the first drawing and it is blue in the second drawing. And in the second case, blue in the first drawing, not blue in the second drawing. That's why I'll just use this probability that the first drawn ball is not blue times probability that it is blue in the second ball. And there are 2 situations here, vice versa. That's why I multiply this by 2. Then plus the probability that the balls are blue. So for the first one, it is not blue. There are 5 red balls plus 3, 8 plus 2 green balls, so 10. There are 10 balls all in all, and 7 of them are not blue. Therefore, this is 7 over 10. And in the second part, it is 3 over 9. 9 balls left, then times 2. So probability that at least one ball is blue is equal to 7 over 10 times 3 over 9, then times 2. For the 2 blues, or so plus 3 over 10 times 2 over 9. 2 blue balls left out of 9. So computing the probability that at least one ball is blue from drawing in this bag with 2 balls, so it is 8 over 15. For the second problem, a number of 2 different digits is to be formed from the digits 1, 2, 3, 4, and 5. Determine the probability that the number is greater than 34. So we have to analyze that the total number of outcomes is the permutations of 5 things, 5 digits taken 2 at a time. Or if we apply fundamental principle of counting, for these 2 different digits, there are 5 available digits. In the first position, we can assign 5 ways in the first digit, and in the second 4, because 4 digits are left. And 5 times 4 is 20, and that is the same as 5 permutation 2. Now let's proceed to this situation, the number of favorable outcomes. So probability is number of favorable outcomes divided by total number of outcomes. So the total number of outcomes, as mentioned earlier, is 20. 5 times 4, or 5 permutation 2. So that is 20. For the favorable outcomes, we have to analyze. Take note the digits should be different. So for a 2-digit number which is greater than 34, and it should begin with 3 first, for that case, only 35 is greater than 34. So there's 1. So n is equal to 5t2, as I said, 20. So favorable outcome 1. So we have to analyze that the only 2-digit number with different digits greater than 34 is 35. And to do that, in the first position, there's only one way we can assign a digit here, which is 3. And there's only one way to assign a digit there. So it should be greater than 34, and it is 30x, 36, supposedly 35, but there's no 6, so it's only 35. Let's show that there's only one way, that there's only one number, 2-digit number with different digits greater than 34 that begins with 3, or it is 30 plus. So there's only one digit that can be assigned here, which is 3. And in the second one, there's also one, which is 5. And that number in particular is 35. For the second case, when the 2-digit number of different digits is greater than 34, there will be 2 in this position, 4 and 5, and after assigning a digit in the 10th digit, which is, we can assign 2, either 4 or 5, then in the second position, there will be 4 digits left. So there are 4 ways to assign a digit in the second place. And 2 times 4 is 8. Therefore, the total number of favorable outcomes is equal to 1 plus 8. 1 times 1 is 1. That is specifically 35 plus 8. So 9 over 20. So the probability that the 2-digit number with different digits is greater than 34 is 9 over 20. Let's proceed to the next problem. If 6 boys and 6 girls are seated at random in a row containing 12 seats, what is the probability that the boys and girls sit in alternate seats? So let's have the figure or the solution. So number of favorable outcome, let's have this guide here, and the arrangement would be in a row. Just concentrate on the boys first, then on the girls. There are 12 overall individuals, so the total number of ways we can arrange these 12 different individuals is 12 factorial ways from the principle on permutations, arranging n different things taken all at a time. So the total number of outcomes is 12 factorial. For the favorable outcomes, let's focus on the boys first. So there are 6 boys, so we can arrange them in a row in 6 factorial ways. And for the girls, also 6 factorial ways. And we multiply it by 2 because there are 2 cases. In this situation, we have boy, girl, boy, girl, boy, girl arrangement. The second situation is we have girl, boy, girl, boy, girl, boy. And I hope you can follow it. So that's the total favorable outcomes in the numerator, and this is the total number of outcomes, 12 factorial. It's computing, so the probability is 1 over 462. Problem 4. 3 French books and 4 Spanish books are to be placed at random on a shelf with space for 7 books. What is the probability that all the books in the same language will be together? The total number of outcomes would be arranging the 7 books in a row, and that is 7 factorial ways. Then in the numerator, favorable outcomes, if you're going to analyze that this is permutations by books. There are two groups, French books and Spanish books. So the formula is for the number of arrangements, different arrangements is number of groups factorial, then number of members of group 1 factorial times number of members of group 2 factorial, and so on and so forth, depending on the number of groups. So therefore, probability is equal to number of groups factorial times number of members of group 1 factorial times number of members of group 2 factorial, all over the total number of ways of arranging this n books, which is n factorial. Substituting, there are two groups. Then this is French books, so 3 factorial. Then this is Spanish books, 4 factorial. So P equals 2 factorial times 3 factorial times 4 factorial over 7 factorial, and that is equal to 2 over 35. Problem 5. Find the z-value of z-score to the right of the mean so that 69.85% or 0.6985 of the area under the distribution curve lies to the left of it. So remember that in the normal distribution, standard normal distribution, the area under it is equal to 1 and the mean is 0. And because this is more than half, more than 0.5, the z-score should be positive. So therefore, do not select these negative values here. So this is the guide, the drawing. That's standard deviation, which is equal to 1 for this normal, standard normal distribution. And this is the area. The total area here is 0.6985. And that's the z-score. Therefore, the density function is, if you can recall, for standard deviation equal to 1, is the integral of the area of this, which is e to the 1 over square root of 2 pi, then e to the negative 0.5 z square, then integrating, so dz. And our limit should be from, supposedly from negative infinity to z, but that is also equal to integral. It is equal to 0.5 because the area of the left half is 0.5 plus integral from 0 to z of 1 over square root of 2 pi e to the negative 0.5 square dz. So that is supposedly it. And thirdly, we use the technique in calculator to find that z there. So this is supposedly 0.6985. So probability is equal to 1 minus the area that lies to the right of z. So 1 minus this area here. And the limits for this would be from z to infinity, positive infinity. And so that the calculator can evaluate the area rapidly, then we choose infinity to be just 10. Do not make it very high because the z-score up to 3 is, the area is bounded by negative 3 to 3 is almost 1 already. So you can even select infinity equal to 5 if you want. So this is 1 minus integral from z to infinity of 1 over square root of 2 pi e to the negative 0.5 z squared dz. So as I said, we choose infinity to be, you may choose 5 if you want, but in this case, I'll just choose 10. And from the choices, because z must be positive, it lies to the right because of this information here, area. Then I just manipulate the choices. We select between 0.52 and 0.53. That's the expected answer. So let's start with 0.52. And it happens that at 0.52, using your calculator, of course, this is calculated approximately using the calculator. So that is 0.6985, really. Therefore, the value of the z-score is 0.52. Now, in your calculator, you have to set the mode to statistics, then press AC, then shift 1 so that it will open the different options and choose distribution. Once you press distribution, which is I think 5, then it will open another options. Then you have to choose Q of Z, and you select 0.52, it will give you the area just to the right of the mean. So it will only give us this value here. Then you add 0.5, and if it is equal to 0.6985, then that's it. So in other words, for the Caltech part, 0.6985 equals 0.5, this area here, plus Q of Z from the calculator. So choose 0.52, and because they are equal, then Z is really 0.52. So that's it for the calculator technique, so that you don't need to memorize the distribution factor for this standard normal distribution. With standard normal distribution, of course, the standard deviation is automatic 1. Then problem 6, an automobile dealer finds that the average price of a previously owned vehicle is 412,800 pesos. He decides to sell cars that will appeal to the middle 60% of the market in terms of price. So find the maximum and minimum prices of the cars the dealer will sell. The standard deviation is 57,500 and the variable is normally distributed. So this time we still use Caltech, and we'll find the z-score corresponding to, because this is the middle 60%, so meaning to say just to the left and just to the right of the mean would be 30% or 0.3. So this is the guide, and we'll find the z-score such that the area bounded by that z-score left portion to the mean is 0.3, and from the mean to the right, that's also 0.3, so that's 60% or 0.6. That means that the z-score 1 is numerically equal to z-score 2. The only difference is z-score 1 is negative. So that's the idea. So using the calculator technique, we'll find the value of z using this Q of z from your calculator, such that Q of z is 0.3. So after several options, several substitutions to 4 significant figures, the value of z1 is equal to negative 0.8416, corresponding to an area of 0.3 or almost 0.3. Therefore, z2 is positive 0.8416. Since z-score is the item, the price, minus the mean price all over standard deviation. So we equate it to that formula. Z-score is equal to the price, which is in this case x1, minus the mean price 412,800 over standard deviation. So solving for x1, the minimum price therefore is equal to 364,408 pesos. So we can make that round off to 364,400, of course. Then positive 0.8416 is equal to x sub 2 minus 412,800 over standard deviation 57,500. So x sub 2, or the maximum price, should be 461,192. So let's make it 461,200. So for the final answer, 364,000 pesos less than equal to x, and x should be less than equal to 461,200. So that's it for this video, and I hope that you were able to follow, understand the explanations, the calculations, and the techniques.